In this example problem, we're going to work on developing the parabolic equation for a vertical curve. We're told to develop this parabolic equation that describes the curve with a PVI at station 46 plus 68.42. And this is for an actual set of design plans. We're looking for a particular vertical curve. We want to find the high point station and elevation as well. So here's our actual set of design plans. This is the curve we're looking for. It's the vertical curve with a PVI at station 46 plus 68.42. And we're going to work through some of the various elements. And all this is given on this set of design plans, but I'll pull them out so we can see them a little more clearly. Starting with our entrance grade G1, that's 6%. And it's very important for vertical curves that we put our grades in percent and our lengths in stations. And also, as we're working with our grades, it's important that we use the positive or negative sign that's associated with each. Our G2 is negative 3.5, so we want to make sure we carry along that negative sign throughout all of our work. It goes in increasing stationing. Positive is for upgrades, negative is for downgrades. We're given that our point of vertical intersection, the PVI, and it's also known as the VPI, is station 46 plus 68.42. at an elevation of 1,058.98 feet. And here's the symmetric parabolic curve that ties these two grades together. We're given the length of 600 feet or 6 stations. We're told we can find the PVC because we know with a symmetric parabolic curve, the PVI is in the middle of the curve. We've got the 600-foot long curve, so the PVC is 300 feet before the PVI. We can also calculate the elevation of the PVC. So we're going to start with that PVI elevation that we were given, and then we're going to subtract off that grade, which was 6% and 300 feet. So 6%, 3 stations, 6 times 3. You could also put in the full 600 feet and then put the percent in decimal to get the same thing, but it's an elevation change in 18 feet regardless of which method you use. So the elevation of the PVC is 1,040.98 feet. And we'll see it plays a prominent role in our parabolic equation. That's why I went ahead and solved it here. We can also find the station of the PVT. It's 300 feet past the PVI, so it's at station 49 plus 68.42. We can now solve for the location of the high point, and it's denoted as X here, and it's the distance from the PVC. So whatever X value we solve for, it's the relative distance from the PVC of this particular curve, and we need to make sure we convert that to the actual stationing. So X equals negative G1 times L over G2 minus G1. So that's negative 6 times 6 divided by negative 3.5 minus 6 equals 3.789 stations. And if you're familiar with vertical curves, we know that the high point is always on the side of the PVI with the flatter grade. So we would expect the high point to be greater than 3 stations, so it puts it on the side of the PVI with the flatter grade, and that's the case. So that's one check that we can look for here with vertical curves. Now to actually find the stationing, what it actually is in terms of our stationing of our actual project, we're going to need to add the X value to the station of the PVC. So we're going to add 3.789 stations to our PVC station. We're going to get a station for the high point of station 47 plus 47.37. We can now develop our equation, our parabolic equation that's specific to this curve. So we're going to plug in our values for G1, G2, L, and the elevation of our PVC. So we have negative 3.5 minus 6 divided by 2 times 6 times x squared plus 6 times x plus 1,040.98. Simplifying that a little further, our parabolic equation for this particular curve, y equals negative 0.79 times x squared plus 6 times x plus 1,040.98, where y is the elevation at any point on the curve, so it's got to be bounded by the PVC and the PVT, and x is the distance from the PVC, and it also needs to stay within the curve. So the minimum value for x is 0, and the maximum value for x is 6, because we're putting this in terms of stations. We need to make sure we use that correct nomenclature. So that was the second thing we were asked for is this parabolic equation We also have the station of the high point. The last thing we need to find is our elevation of the high point, and we can use our parabolic equation and our x value. So we're going to plug in 3.789 for our stations for x. So y equals negative 0.79 times 3.789 squared plus 6 times 3.789 plus 1040.98 equals 1052.35 feet. That's the elevation of our high point. So our high point occurs at station 47 plus 47.37 at an elevation of 1052.35 feet. And the curve is described by our parabolic equation y equals negative 0.798x squared plus 6x plus 1040.98.